There are many different kinds of research used in the sciences, but one of the number one ways that we do research is look for correlations. So in this video, I'm going to explain correlation. We do a correlational study when we're interested in the question, are X and Y related, X and Y being two different variables? Or is there a relationship between A and B, two different variables? So what we do when we're interested in answering this question is we have to go find a whole bunch of subjects, randomly select them from the group that we're interested in, the group we call our population, and then we measure those two variables, and we make a scatter plot, a little graph that shows the distribution of these scores, and also we calculate what is called a correlation coefficient. So here we have an example of a scatter plot. On the scatter plot, each dot, or in this case the little diamonds, represents two scores. So if you go straight down from a dot, it tells you the score on the x-axis, whichever variable that is. And if you go straight across from a particular dot, you get the score on the y-axis. So in this case, we have a positive correlation because the dots tend to go up from left to right. That means high scores on X are related to high scores on Y, and low scores on Y are related to low scores on X. These two variables are correlated in what we call a positive way. In this scatter plot, we see the dots all are very close to a straight line that moves upward from left to right. That means that we have a very high positive correlation between the two variables that were measured. And here on this scatter plot, remember each dot tells you two scores. Go straight down from the dot, you find a score on the x-axis, and straight across you find the score on the y-axis. This representation of dots is what we might think of as a medium positive correlation. It's a positive correlation because the dots tend to go up from left to right. That is, low scores on one variable tend to go with low scores on the other variable. So if a person has a high score on one variable, they probably have a high score on the other variable, although there are a little bit of exceptions. So this is a medium positive correlation. This scatter plot represents a negative correlation. We say negative meaning that it's backwards. That is, if a person has a score that is low on one variable, they probably have a score that's high on the other variable. So low scores tend to go with high scores, and high scores tend to go with low scores. So you see the dots on the scatter plot tend to go down from left to right. That is, a high score on the x-axis is usually associated with a low score on the y-axis, and a low score on the x-axis goes with a high score on the y-axis. So remember, in a correlational study, we get a large group of subjects randomly selected from our population of interest. We measure two different things about those subjects, and then we make a graph called a scatter plot. Each dot on the graph tells two scores. So each dot is one subject, but it tells two scores about that subject. If the dots arrange in the order I'm showing here, this is a negative correlation, but there's a lot of exceptions, so this would be considered a low negative correlation. Here we have three scatter plots. The one on the far left is a positive correlation, but a lot of exceptions. The middle one is a negative correlation, but a lot of exceptions. And then the third one on the right, the dots are scattered all over the place, so there is no relationship between the two variables that are measured, so there's no correlation. Here we have the same illustration, but this time with explanation. We have a positive correlation, a negative correlation, and no correlation. The positive correlation shows us as one variable increases in score, the other one tends to increase. The negative correlation, when one variable goes up, the x, y, or the y-axis, when the scores go up, the other ones go down. That's called a negative correlation. Negative doesn't mean bad, it just means reverse. And then the third pattern is no correlation. When we measure two variables in a large group of subjects, we can then take those numbers, those scores that we get, and put them in a formula called a correlation coefficient. We can calculate a number that can be 0, meaning there's no correlation. It can be 1, meaning there's a perfect correlation. And of course, it can be any place between 0 and 1. Plus, it can be either positive or negative, telling us which direction the relationship goes. So 1 means a perfect relationship, no exceptions. 0 means no relationship. And then you can have a score anywhere in between. This is called the correlation coefficient. This illustration shows you how the correlation coefficient is related to the scatter plot. So as you see the scatter plot changing, look up above and you see correlation coefficient is changing. The correlation coefficient is represented by lowercase r, the letter R. And here we see 4 illustrations of correlations and no correlation in the bottom right, and then the line that indicates the amount of correlation that's there. Here is a summary of scatter plots and correlation coefficients. So you can see the scatter plot, and then down below it is the correlation coefficient. In the very middle, we have dots all over the place. The R is 0. On the very, very far right, we have dots all lined up in a straight line going down from left to right. That's -1 correlation. And on the far left, the correlation is positive. And the very last one, correlation is +1. Now here's a joke. Everybody who went to the moon has eaten chicken. Oh, good grief, chicken makes you go to the moon. Well, of course, the conclusion is false, because this person has made a very common mistake to think that a correlation proves that one variable causes the other. Just because 2 variables are related to each other does not mean that one causes the other one. In science, we say that correlation is not causation, or correlation does not prove causation. So for example, if we measured ice cream sales, how much ice cream is sold, and we also measured how many shark attacks occur, we would find that these two both correlate to each other because they both occur when there's warm weather. So ice cream sales and shark attacks do not cause one another. They're both related to a third thing, in this case, the weather. Similarly, if we measured ice cream sales and people's level of sunburn, we'd find a positive correlation. When ice cream sales are high, sunburns are more common. But of course, this is not a causation, an example of cause and effect, because they're both related to the weather. Okay, I hope you learned a little bit about correlation. We measure 2 variables in a group of subjects and we see if they're related to one another. They can be positively related, they can be negatively related, they can have a relationship of 0. We can calculate a correlation coefficient. We can make a scatter plot that gives us a picture of what it looks like, but we must remember that if you have a correlation, that does not prove that one variable caused the other. That is a very, very common mistake that's made all the time in newspaper articles, magazine articles, on network news, and so on. So watch out for that mistake. Correlation does not prove causation. What correlation shows us is that 2 variables are related to one another. You can predict, knowing one of them, the value of the other one.